Hi, Math Stars. Welcome to another week of this remote learning. Today, we will be working on this lesson 8 problem set. And this week, it will be just building upon what we've been working on last week with the area models and most importantly, showing that fractions are equivalent. Today, we will not only be using just the area model, we will also be saying that fractions are equivalent by using multiplication. So let's do some problems together, and then you guys should be all good to go on your own. So first, let's start off with question A. We read that each rectangle represents 1. So each rectangle just represents one whole. And it tells us that the shaded fractions have been decomposed into smaller units. So every time that this figure is cut up, we have smaller units, right, math fans? And what we're going to do is we're going to express the equivalent fraction in a number sentence. This is our number sentence using multiplication. Okay. The first step in this problem is to always look at the original figure. Always look at this original figure and always look at the original times it was cut up. So as you can see by these dark lines, we know that it was originally cut up 3 times. And how many of those times was it shaded? How many are colored in? So as we can see, 2 are shaded in out of 3 total original cut up figures in this rectangle that represents 1. And then what they went ahead and did is they cut it 1 time horizontally. So now, instead of having 3 total figures in this one shape, or I've been calling them chocolate bars in this one chocolate bar, it now turns into 6 total. 1, 2, 3, 4, 5, 6. We now have 6 total pieces in this chocolate bar, and 4 out of those pieces are shaded. And that's pretty much what we did last week. We learned that by cutting up this figure into more pieces, we are able to get equivalent fractions. So we know that 2/3 is equal to 4/6. How else can we show that? How else can we show equivalent fractions? Well, we can show equivalent fractions also by using multiplication. So they cut each original shaded piece, or each original piece in this one figure, in half. So instead of now 1 piece, we had 2 pieces in each figure. And they show that by multiplying it by 2. So then we know that 2 times 2 is 4, 3 times 2 is 6. And that once again shows that 2/3, or 2/3, is equal to 4/6. Okay, let's go ahead and also try B right now. So for B, ignoring this dashed line right now, we're only looking at the fully drawn out lines. We can see that in this one rectangle that there were originally 4 pieces in this original rectangle, because we have 1, 2, 3, 4. How many of those pieces were shaded in? Well, 1, 2, 3 of those pieces were shaded in. So 3 out of 4 were shaded in. And then what they did is they went ahead and cut up this chocolate bar, cut up this area model into even more pieces by drawing a dashed line, or 2 dashed lines horizontally. 1, 2. So now, how many pieces do I have total? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pieces total. How many of those pieces are shaded in? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of those pieces are shaded in. Okay, so we know that 3/4, or 3/4, is equivalent, or is the same as 9/12 or 9/12. So let's be clear really quickly that equivalence, so equivalent means the same, okay, or equal. So how can we rewrite this as a number sentence using multiplication? Well, we can say that 3/4 times 3 in this case, because each original piece was cut up into 3 pieces. So each of these 4 pieces was cut up into 3 pieces, and that's why I'm multiplying it by 3. So 3 times 3 to represent the shaded is 9. 4 times 3 to represent the total is 12. So we can say, once again, that 3/4 is equal to 9/12. Okay, so I want you guys to try C and D on your own. And also, you guys will be doing number 2 on your own. For A, we are decomposing into tenths. So they want you to do the same exact thing as you did up here, but you're going to draw your own dashed lines horizontally. So your own dashed lines from left to right. So in this first figure, think about how many lines you need to draw in order for these 5 pieces to turn into 10 pieces. So how many lines do you think you would need to draw for those 5 pieces to turn into 10 pieces? And for 2B, how many horizontal lines do you need to draw for those original 5 pieces to turn into 15 pieces? Okay, and go ahead and try to also write a multiplication number sentence, just like we did for 1. Okay, and then let's go ahead and do a couple, or let's do one problem under 3 together right now. So we can, 3 asks, draw area models to prove the following number sentences are true. Okay, simple enough. So essentially what they did is they took away this lovely area model, this lovely chocolate bar, and they're trying to push us to visualize this stuff without our chocolate bar. But I am going to use it just for the sake of easy visualizations for 3A. So I know originally I have 5 total pieces. Excuse my bad drawing. 1, 2, 3, 4, 5. I know that 2 of those pieces were originally shaded in. 2 of those pieces were originally shaded in. And I know that I then needed to get to 10 total pieces. So I need these 5 pieces to become 10 pieces. Okay, let me go ahead and draw one horizontal line from left to right to see if I now have 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did it, all good to go. And I see that 4 are shaded in. So super duper good job. I drew the correct number of horizontal lines, and I show that 2/5 or 2/5 is equal to 4/10. How could I have written this in a number sentence? How can I have shown that 2/5 is equal to 4/10? Well, I could have just multiplied the numerator, or the number on top, and the denominator, the number on the bottom, by 2, right? Because each of the original 5 pieces were cut up into 2 pieces. So I could just multiply each of them by 2. And I know then that 2 times 2 is equal to 4. 5 times 2 is equal to 10. So I can say that 2/5, or 2/5, is equal to 4/10. Okay, so I want you guys to go ahead and try B, C, and D on your own. Okay, 4 asks, use multiplication to find an equivalent fraction for each fraction below. Okay, what's super easy about this, math stars, is equivalent. How can we find equal fractions? How can we find an equal fraction to 3 over 4? Well, all I need to do is multiply the numerator and the denominator by the same number. Okay? So I could do 3 times 2, 4 times 2, 3 times 2 is 6, 4 times 2 is 8, and therefore I know that 3/4 is equivalent to 6/8. I could have went ahead and multiplied 3 and 4 both by 3. 3 times 3 is 9. 4 times 3 is 12. Okay, so I also could have said that 3/4 is equal to 9/12. So you could multiply it by any number you want. Just be sure that you're multiplying both the numerator and the denominator. And that's how you get those equivalent fractions, okay? And if you need to, go ahead and list your multiples, okay? I could have very easily, if I forgot, list my multiples of 3 really quickly, and list my multiples of 4 really quickly, just so it's fresh in my head and just so it's right there. And then 5, let's go ahead and do one problem in 5. So 5 asks, determine which of the following are true number sentences. And then they want us to correct the ones that are not true. Okay, let's go ahead and do 5A. So I need to pretty much show that these number sentences are true, or try to see which ones are true and fix the ones that aren't true. Okay, so I just learned up here that I know that equivalent fractions, I need to multiply the number on top and the number on bottom both by the same number. I need to multiply the numerator and the denominator by the same number. So I know that 4/3, let's try right off the bat, let's try 2. 4/3 times 2, 3 times 2. So 4 times 2, well, that's 8. 1, 2, that's 8. 3 times 2, 1, 2, that's 6. So then I know that an equivalent fraction to 4/3 is 8 over 6, or 8/6. So I know that 4/3 does not equal 8/9. 4/3 is equal to 8/6, or is equivalent to 8 over 6. Okay, so I know that 4/3 is not equivalent to 8 over 9 because when I multiplied by 2, when I multiplied by the same number, by the numerator and denominator, I did not get this answer. I got 8 over 6. So this is equivalent and 8/9 is not. Okay, so go ahead and try B, C, and D on your own. Please always feel free to contact me or join office hours if you have any questions. Have a great day, Math Stars.